go.
Okay, so we're going to get right into some SolidWorks, either refreshers if we had kind of touched on it last week, or some brand new sketching tips and tricks, different other tips that we want to go over before we start getting into parts. But the idea of today is that we're going to get you some modeling practice. I'd sent out a little link, and we can send it out again to a drive location where I've got some drawings saved. But basically, we want you to be able to open up these drawings and get started on some SolidWorks modeling. And then you'll be with your group, your mentor, in case you have any problems, if you want to ask for help. And then we should be able to take these, save the files as STLs so that we can actually 3D print them. And then you'll put them in the GrabCAD so that we can actually print the things out for you. If you're around, we can have a drop-off for you. Okay, so let's get right into sketching tips and tricks. So the first one that we want to go over, just because it's pretty useful sometimes, is this selecting a circular edge. So most of the time, if you're clicking on a circle with the Smart Dimension tool, what it'll do is it'll snap to this center point. But sometimes what you want is actually for it to grab the outside of the edge. So what this will let you do if you hit Shift while you are in the Dimension tool is it'll pick that up and it'll let you actually dimension between those, whereas normally it would just do kind of the length of this line. Another thing that's really powerful, we were talking last week a lot about construction geometry. So when we're actually trying to make construction geometry, we can either start with shapes that are solid and then turn them into construction using a sidebar that pops up on the left side of your screen. That's this for construction box. Or when you click on something and you kind of hover over to the right, it's like a motion that you'll get down by the end of this, I hope. There's like a little pop-up menu that shows up right here. And then you can click this here that will change it to construction geometry. I should ask, you guys can see my mouse, right? When I'm moving it around to point at stuff.
Yes, we can.
Cool. All right. So yeah, so you take a solid shape and it just converts it to the construction instead. Okay, so originally I was going to try to do breakout rooms, but I think time-wise it's going to make more sense for us to just talk about this and then get either try this out in breakout rooms later or just have this as an exercise to look at. But basically, if I was going to apply some of those skills that we just talked about, I could draw this up, this shape, and then convert this line to construction geometry. I could pick up this edge to practice that dimension technique we just talked about. I could make sure that I have the right relation set. So I could set an arc here and then make that tangent to the lines I just drew. And then I could also use offsets to try to save myself some work if I want to just make a larger shape around a shape I've already drawn. So in this case, you have a slot down the bottom, and we wanted to create a larger slot. We could use the offset tool to make that happen. So yeah. And then just reiterating some feature generation tips and tricks. When we're making parts, sometimes it's nice to use reference geometry. So we might make planes in the middle of a part using different definitions. So in this case, we have an existing surface, but we want a plane that's offset a certain amount. We can set a distance from that surface to create a new plane. Or let's say we wanted one right in the middle. We can select these two surfaces and then SolidWorks will populate that right in the middle. And this can be useful for different things, mainly mirroring and circular patterning or linear patterning. any kind of patterns, just to save you some work. So you can make one feature and then repeat it a whole bunch of times so you don't have to manually do that or make a big convoluted sketch. All right, so if we had time to practice this, we could basically apply those skills. We could make a couple features and pattern them around using reference geometry to mirror and circular pattern things. So if you want to try those with your mentor, just reference back to this and then they'll be happy to help you out. All right, so an important thing for today is we want to go through mechanical drawings and turn those into solid models. Something to get used to is the way you actually would read this drawing. So in this case, we're going to be using what's called third angle projection, which I think the easiest way to think about that is if I had an object that you're looking at. Can everybody see my screen? Or what I'm holding in front of me?
We can.
Okay, so if I had this dry eraser, and I was going to do a drawing of it with third angle projection, I would maybe have this rectangle in the drawing, and then if I was going to project it, then it's kind of a motion of sweeping it. I like to think of it as sweeping it out from under its feet. So if this was like standing, it would kind of sweep out to be like this. So it'd be this face that's kind of next to it in this place. So you can see over here, we have a front view, and then if we swept that out, it would be a top view over here. And if we swept it out to the other side, it would be a side view. And then usually somewhere on a drawing, we'll also have an isometric view. And we'll get used to this as we look through some of those drawings. And if you're having trouble figuring out what something is supposed to be, you can ask your mentor for some help in reading it. Section views are pretty helpful. So it's a similar thing to this projection, but instead of being kind of the side view of just whatever shape it is, you're cutting it in half as well. So in this case, you have a hole through here, and when you cut that in half, then you can see the hole comes through, but you can also see a cross hatch across, which shows that there's actually solid material there. Detail views are also pretty helpful. So in this case here, there's just a circle around the detail, and then it says see detail A. And then over here, there's a detail view that shows a bigger version. Usually you do this if you have like some small tiny features on a big part. You can do a detail and kind of explode it over to the other side so you can see it a little bit better. All right, and then just to go over part creation one more time, especially useful at the beginning is to make sure you're in the right set of units. I think by default, SolidWorks will have you in millimeters, so we're modeling our parts in millimeters today. But if you were to model in inches, it's really important to change that ahead of time. So down in the bottom right corner, there's this dialog box that comes up to change to IPS. If you don't change that beforehand, it's kind of difficult to change afterwards, because if you model in millimeters and then switch to inches, it will keep all of the same sizes. So it'll just convert it to inches, so it won't quite be right. Geometry-wise, it'll look the same, but it'll be scaled the wrong way. We're gonna select planes or surfaces to make sketches, and use those 2D sketches to create features. And then as we build more features, we'll get kind of more complex shapes as we go. We're trying to use mirroring and patterning as much as possible to save ourselves some work. Also important is setting materials. If you're gonna actually use these models to figure out mass and stuff like that. Something that's helpful on the drawings that we're providing you is that we've set, if you set material to aluminum 6061 T6, your mentor can help you figure out which one that is in the dropdown. But basically you right click on this material on the sidebar, and then you can change it. But the masses are shown on the drawings. So you'll be able to know, okay, I've got this geometry right if the matches are matching up. All right. One more important skill that we want to cover is, actually, let me exit presenting, is importing CAD files from online vendors. So I'm opening up mcmastercar.com. I didn't want to do that. We're going to import some screws or show you how to do that. So for the assembly that we're going to have you make today, we're going to be looking at M3 screws. So I'm going to just go to socket head screws. I'm going to select what type of threads I want. Master has all of the hardware you'll ever need for any engineering application, mostly. So I'm going to pick M3. We want a 25 millimeter long screw. And then we don't super care about its surface finish, so I'm just going to pick black oxide. It's kind of a basic one. And then just right in here, I can save this. So they'll provide on this vendor website 3D models that you can just download. So this is a SolidWorks part that I can just save. And then if I'm working in a group that's using GrabCAD, I want to make sure that I'll put it actually in a folder that everybody can access so that when they pull files, it will actually be there. If you stick it in your downloads folder, somebody else will go to try to open up your assembly and it'll say, oh, this is in Scott's downloads folder. I don't know where it is. So make sure that you're saving that to GrabCAD, and we can help you figure that out as we go through.
Important note, when you do that, it will say your username so everyone knows exactly who did it too.
Yes.
Error is the worst and the bane of most club CAD existence. So please don't do that.
Yeah. So I'm actually going to not do that so I don't put it in a random spot. But that's how you would do that if you're going to try to do that properly. Okay. I think that's pretty much it for my spiel. So we should be able to jump into our breakout rooms so that we can get started on our modeling activity.
Awesome. Thank you, Bryce.